Dun, 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 dun. Hi, I'm Jim Jankowski, and welcome back to my channel. If you're new here, then you're in for a ride. But if you're, alright, yeah, part two. This is part two of the video I did earlier. We're discussing plate tectonic and tectonic plate boundaries. So, last time we discussed what these are and a divergent plate boundary where two plates go apart. So what we have next are convergent plate that's a Cartesian coordinate system. Convergent plate boundaries where they go together, and transform plate boundaries. So we're going to be talking about these two in this video. So, as discussed last time, there are two types of crusts, oceanic crust and continental crust. So oceanic crusts are thin, and then they're really thin, and there's magma underneath. And then continental crust, these are mountains, it's super thick. So, at a convergent plate boundary where there are two types of convergent plate boundaries. So there's meeting with the ocean and meeting with two continental plate boundaries. So when you have an oceanic plate boundary and the continental plate boundary, and they go together, here's what happens. So this creates subduction in a subduction zone. So, hello, welcome back. I have drawn this beautiful diagram that may or may not be accurate of a subduction zone. So, we have multiple things going on here. So, a subduction zone, oceanic plate and continental plate. So, we have an ocean right here. And then the oceanic plate is in green, and it's going down underneath the continental plate. So, as it's going down into the mantle where it's hot, the crust is actually melting. So that creates magma, and then the magma rises. And when it rises, it forms these volcanoes. So like in Chile, there are lots of volcanoes, and that's partly because of a subduction zone. So all this magma is rising up and making volcanoes. So it's melting, it's going into the lithosphere right here, and then it's going into the plastic like asthenosphere underneath. And this creates earthquakes, this creates volcanoes, and yeah, that's it for oceanic versus continental. Alright, this is how the Himalayas were formed. Okay, so right here we have, this is a drawing of a convergent boundary between two continental plates. So here's what's happening in this drawing. So when these two continental plates, they're really, really thick. So versus subduction, where one just easily forces itself underneath, these are really, really thick pieces of crust. So what actually happens is one, when they go this, they're like this, and then one forces its way up and the other forces its way down. So it goes something like this. And then because it's being forced up, there are actually mountains that form like right here. And so this is the magma underneath, and then these are the mountains being formed, and this is actually how the Himalayas were formed. Because during continental drift, the places where the continents were just minding their own business, and Eurasia over here was just chilling. That's Eurasia, and then India was like woo. And then India was like, bam. And then these two continental plates converged, and they made the Himalayas. And they're still converging, and that's why the Himalayas are slowly rising every year. So that is all for continental plates. Moving on to transform plate boundaries. This right here is an example of what a transform plate boundary might look like. So this is transform. So transform basically means one plate's going this way, plate's going this way, and then they rub against each other. So transform plate boundaries have a lot of earthquakes that occur because the plates, their sides aren't like smooth, they're really rough. So when they scrape against each other, they're always moving, but sometimes they get caught, and then they're stuck kind of, but it builds up tension, and then when the rocks reach their elastic limit, they break, and then that causes an earthquake. So that happens a lot here because it's all moving here. So what's happening in this picture is it's just a normal thing, and then it's been moving side to side. So sometimes rocks can be like cracked and moved, and like things are displaced, but some of the things that are most interesting are like a stream. So this actually happened at the San Andreas Fault. So a stream is just moving, and then along the fault it goes up, and then it keeps on going. So it'll literally be like this, and then it'll go like that. So that's just a thing. It just shows how much it's moving. So yeah, that's basically it for transform faults, and that wraps up our continental plate tectonics unit. Thank you for watching. Goodbye.